A differential equation is a mathematical equation that relates some functions with its derivatives. The function usually represents physical quantities, the derivatives represent their rates of change, and the differential equation defines a relationship between the two. Differential equations first came into existence with the invention of calculus by Newton and Leibniz. Isaac Newton created three different types of equations, which were dy over dx equals f of x, dy over dx equals fx comma y, and x1 dy over dx1 plus x2 dy over dx2 equals y.
Jacob Bernoulli proposed the Bernoulli differential equations in 1695, which is an ordinary differential equation, known as y prime equals 2x to the power of n minus 1. There are some advantages and disadvantages with the method. For example, in advantages, it is simple and direct, and can be used for nonlinear IVPs. And in disadvantages, it is less accurate and numerically unstable. Approximation error is proportional to the step size h, hence good approximation is obtained with a small h. This requires a large number of time discretization, leading to a larger computation time, and usually applicable to explicit differential equations.
Hello, so today Fabian and I will teach you how to approximate using differentials. Problem: square root of 16.5. We're going to separate it in two, which will give you the square root of 16 plus 0.5. This number will be our x, and this number will be our dx. Using this formula, we're going to find our f of x, which is square root of x, and we have to derivate it, giving us the derivative of f of x equals x to the 1/2, which is 1/2 x to the negative 1/2, which gives you 1 over 2 x 1/2, leaving us with the final answer of 1 over 2 root of x. This will be our our derivative of f of x. The formula for us to find the approximate using differential is f of x plus delta x equals f of x plus f prime of x times dx. If we substitute with the values that we found earlier, it will give us root of x, which is 16, plus f prime of x, which gives us 1 over 2 root of x, times dx, which is this, times 0.5. And if we solve it, we get the final answer of 4.062. If we were to put this number into a calculator, it will give us 4.062. And this answer, with this answer, you get that it's correct and you did a good approximate.
Okay, so here's another example. For this example, we will be using the square root of 8.2. So if we get in our calculator the square root of 8.2, it is going to give us the value of 2.8635. So we're gonna round this up to 3. So 3 squared is equal to 9. So we're gonna put in the square root of 9 minus 0.8. And this is going to determine that our x is going to be equal to 9 and that our dx is going to be equal to 0.8. Now the next step is to determine what is going to be our function. So our function in this case is going to be the square root of x. So we derivate the square root of x to the 1/2, which in turn gives us 1/2 times x to the minus 1/2, and then we just simplify algebraically. Like this, yes. So this is oops. Okay, so now for the final step of this process, we know that f of x plus delta x is equal to f of x plus f prime of x times dx. So we using this we can find our final value, because we know the value of f of x, which is we determined that it was going to be the square root of x plus f prime of x, which we found also, and dx, which we also determined in one of the first steps. So we just substitute f of x plus delta x is equal to f of x, which is equal to the square root of x, plus f prime of x, which is equal to 1 over 2 the square root of x times dx. And dx we had determined that is negative 0.8. So we just multiply this by negative 0.8, which in turn will give us that f of x plus delta x is equal to 2.86666 and so on.
Doing this project was very interesting since we learned many things. We have always used the formulas in class, but we never knew that the formulas had their story of how they were created. We learned to work better in teams and to help each other out when someone doesn't understand perfectly. We also learned the advantages and disadvantages of the formulas and how they work out and how and when to use them. This project was a perfect one to close the semester, and even though it wasn't the hardest project we have done, I think it was very useful for our lives and for us to know better that topic.